Okay, we're back with video lesson number 2. I would like to remind you guys that the whole topic is surrounding functions, and I'm going to make a summary of what I discussed on our previous lesson. Before I begin, I would like to remind you guys that the idea is that you watch the complete video. If at any time you have to make a pause and go back to check a procedure and then restart or continue with the video, it's perfectly fine. Just don't skip parts of the video. Please be sure to see the whole video in order. Number 2, remember that I have a few exercises on the video. So if you guys would like to make a pause, finish the exercise, and then wait for me to solve the exercise, that's perfectly fine. Also remember that you have other classmates around you, so please be sure to either help them if they need any help, or just give them their space and time to do their work. You can work in pairs or in groups, or also you can work individually. And then of course, if someone else has a solution or another question, you can share ideas within each other. And finally, remember you have to show evidence of your work in Google Classroom. The assignment will be created for you guys to be able to take a picture of what you've done, notes of your notes on your notebook or your iPad, or the exercise on your notebook. You just take a picture of the work you're doing so I can verify that you guys were working during the time in that lesson. Let's begin. So let's make a quick summary of what I did on the last lesson. I started by discussing the composition of functions, and I said that we had different possible combinations. You can have a composition in which they ask for a particular number, or like on exercise C, you can have a composition in which the final answer is given with a variable. This is part number 1 of this section. Then I made the introduction of the absolute value. In this case, we're talking about the size. So what is the distance of the number to 0? And the discussion was that every single time the answer is positive. And after making the drawing, as you guys might remember, it's a V-shaped graph. We did an example with absolute value of x, and then we did an example with absolute value of x minus 1. So those were the 2 examples I was using for the absolute value function. And then finally, I finished by making an introduction to exponential functions in which the index is the variable, and we made the drawing of 2 with the power x. The graph looked like this. A few features important for this case is that what we said is there is an asymptote. It's a horizontal asymptote over here on the left. That means that the graph goes down and down and down closer to y equals 0. And then on the right side, that the function is growing very fast. So we're jumping super fast going up. So this function is called exponential. And then finally, after we did the table and the graph for this exponential function, I made a proposal. The proposal is the following. What I said was, consider this case. Gx equals 2 with a minus x. And the idea was for you guys to try and see if you can find the final graph of this function. Now the whole idea is that you guys use a table of values. That's the reference for us to make the graph. So let's see how that goes. So once again, I'm using the table of values as a reference. I've chosen a few numbers, -2, -1, 0, 1, and 2 for the drawing. And let's see what happens. So let's begin with -2. So that will be 2 with a power -2. So that means 2 with a power 2, and the answer is 4. That is for number 1. Let's continue. -1. that will be 2 with the power minus -1, and that's the same as 2 with the power 1, in which the answer is 2. Then the next one is 2 with the power 0, and you remember that any power 0 is always 1. And then let's continue. 2 with a power -1. By using the index laws, that's 1 over 2 with the power 1, and that's the same as 1/2, or 0.5. And then finally, 2 with the power -2, which is 1 over 2 and a power 2, or which is the same 1 over 4, which is 0.25. Okay, so if you've done that one before by yourselves, you can see that the numbers are quite similar to the one we were doing before. Like, look at the answers. We have 4, 2, 1, 0.5, and 0.25. Very similar to here. We have 4, 2, 1, 0.5, 0.25. The only problem is that we're changing the order. So let's go back to this one. Take a look that now we're starting with 4. 4 is the highest one. So let's make the drawing. Of course, there should be a difference in terms of the graph because the function has a new expression. Take a look here on the graph. I'm sorry, on the function itself, it's no longer 2 with the power x, it's 2 with the power -x, so that's why there should be some differences there. Let's see the drawing. So we have on -2, the answer is 4. So it should be around up here. -1, the answer is 2, and around here. On 0, the answer is 1. On 1, the answer is 0.5, so around here. And then finally on 2, the answer is 0.25, so around here. So if we do a line connecting all of them, take a look that the line goes something like this. Okay, so we have the little points here. Those are the points that we're using from the table. And we have an asymptote here, and the function is going closer to y equals 0. Okay, so differences. Take a look at what we have on the left side. It's a function that when the numbers are extremely small to the left, meaning that very, very negative, -3, -4, -5, the function is super, super, super big. So what we're saying is that as you move to the left, the function is growing exponentially. But as you move to the right, it's completely the opposite. It's going down, it's decreasing, and it's going very close to y equals 0. So again, we have an asymptote. And that's it. Those are two very good examples of what's happening with the exponential function. Now, as I said before, there is quite a nice relationship between this function and the one on top. Of course, they have different shapes. One is growing to the right, the other one is moving to the left. But when you think about the table and features that they share, for example, there's something that is very important. Take a look at both of them. When you evaluate in 0, the answer is 1. Let me go back to the previous one. When you evaluate in 0, the answer has to be 1. So there are some features that are shared by both of them, so I would like to make a summary of the characteristics. For the characteristics between them. So let's have them both on the same graph. So from this summary, take a look at the information we have. Let's erase this. Okay. So we have 2 with the power x, the one that grows to the right, going up. Then we have 2 with the power negative x. It's growing, but to the other side. So one is increasing, the other one is decreasing. But there is information that is shared by both. Take a look that they both have asymptotes on y equals 0. So this is important because the asymptote is present for both. So this is a function that has an asymptote on the x-axis. And then another thing that they both share, that it's important for you guys to point out, is that they both intersect the y-axis at 1, this one over here. That means that both of them, when you place a 0 on the function, the answer will always be 1. Remember that a with the power 0 is always 1. So that means that both functions, in this case, intersect the y-axis at the same point. So there is an interlapping between the two functions. And that's it. I mean, I think that this graph that shows the summary of both of them together is quite useful just for you guys to see what's happening. Now, for this example, take a look that the graph only involves -2, -1, 1, and 2. But of course, if we would like to be a little bit more ambitious, or for example, in your own notebooks, you can continue the graph with 3, you can continue the graph with 4, continue with -3 or -4. It's up to you. Normally, you can extend the graph as much as you can, or you want. The thing here is that with only 5 numbers, from -2 all the way to 2 is more than enough because you can see the behavior of the graph itself. But once again, if you would like to add some additional numbers, it's perfectly fine. So, before we continue, very quickly, we did the construction of the exponential function in which the graph grows to the right as numbers are greater, 2, 3, 4. And the second one, it's the opposite way around. As you move to the left with -2, -3, then the function has very high values. So those two are the basic exponential functions. We're going to have more in the future, and we're going to do some changes to them. So I'm going to show you a few examples in which they're not so easy to be drawn like the ones we have right now here on this page. But at least the positive thing here is that you guys have your graphic calculator, so you should be able to make a graph without a problem. So on both previous exercises, I was doing the graph by hand. I was using a table of values, but now we can move to an example in which we don't need to depend exclusively to a table of values. So I'm going to show you the construction of these functions, and you will be allowed to use the graphic calculator. Last week I explained how to create table of values with the graphic calculator. You are also completely capable now of drawing any type of function. So let's begin with this exercise. Let's focus on this. fx equals 3 with the power x plus 2. They're asking us to find the values of those three expressions you have over there, f of 0, f of 2, and f of -1. Now, in a few seconds, I'm going to show you guys the graph itself. So take a look how the graph will be available. So what I'm going to do is the following. Using this blank space in the middle, I'm going to find how much is each of the expressions in front. Once we have the answer, I'm going to save those numbers, and then I'm going to move down and show you the graph itself. So once again, we're going to find the values right now, and then by using the graphic calculator, we're going to find the graph, and then we're going to check that those three values are correct. So I'm checking the next slide for you guys to know where I'm moving to, but again, we're going to start first with the three values, and then we're going to continue with the next section. So let's see if we can solve this together. So the first thing is we would like to change the function in 0, and we would like to know what will be the answer. So this is 3 with the power 0 plus 2, meaning that this is 1 plus 2, which equals 3. So for the first one, we're going to say that this one has a value of 3. For the second one, they're asking us to change the function at 2. So remember, this is an exponential function, so that means that we have 3 with the power 2 adding 2. Let's see how this looks. So for this case, that will be 3 with the power 2, that's 9. And 9 plus 2 is 11. And finally, what happens with -1? So f with a -1. Let me add first the answer here. So this is 11. So f with a -1. So that means 3 with a -1 plus 2. That's the same as 1/3 plus 2. And you can say that this is 2.333. You can use your calculator if you want to find that exact value. You can leave it as a decimal or you can leave it as a fraction, whichever you prefer. Okay, so we have the 3 values. So this is around 2.33. Okay, perfect. So what are we doing here? We're just evaluating 3 specific values in x. We know now the corresponding pair, in this case in the y-axis. And now what we're going to do is take out the calculator and check that the graph of this function follows this pattern over here. So let's see if that's correct. So let's move between them. So first of all, we know that f of 0 has to be 3. So let's check that over here. So f here is to 0. And what they're saying is that the exact value is in 3. So this is correct. We have 3 exactly in 0. Number 2. They're asking us for f of 2. They said that the answer is 11. You can see from the graph that number 2 is here. So we will have to move all the way up here. So what we will say is that at some point, once the graph keeps on going up, it will go through the 11. So it looks like it's perfectly fine. And then finally, the third one. The third one is on -1. The answer has to be 2.33. So let's check that with -1. -1 is around here. And the answer, this one over here. So it looks perfect. It looks like it's quite close to the one that we were looking for. So what we're going to say is that by using the graphic calculator, we can confirm effectively the following: that f of 0, it is 3. That f of 2, yes, for sure, it's growing up. It will be 11 at some point. And that on -1, the answer is 2.3 approximately. Okay, so those 3 points have been confirmed. And then finally, we would like to check where is the asymptote. And the asymptote is on the left side. Take a look how the graph is moving towards, as you move to the left, as you move in that direction, the function is going closer and closer and closer to y equals 2 in this case. And this is important because the asymptote is also part of this function. So 3 three things important for this case. Number one is that for each and every value that you were checking, there is a pair that can be confirmed with your graphic calculator. Number two, once again, as you see the shape of the graph, it looks that we have a asymptote, a horizontal asymptote towards the left. In this case, the function is getting closer and closer and closer to number two. And then finally, that if you guys would like to extend this line a little bit, you can now work with some additional numbers. For example, you can work with 3, you can go with 4, 5. I mean, it's up to you how many numbers you would like to include in your graph. The good thing is that now that you're using the graphic calculator, I mean, there's no real difference on how many numbers you include, because the calculator will do the graph for any number you want. So you can expand your graph as much as you can. Now let's clean this a little bit. So once again, we have the intersection here. Okay, and it looks like as we go up, for sure, this has a shape that looks like an exponential function. Now, we were completely sure this was exponential because take a look at the criteria over here. They're saying that the function is 3 with the power x, so the index is necessarily located on the power, and then plus 2. And that's it. That's how we can find the value of a specific function, and then with the graphic calculator, you are allowed to confirm your answer by making the drawing. Okay, let's continue with number 2. Now at this point, especially that you saw what I did before, you can pause the video and try this one by yourselves. If you feel that it's too difficult, that you need help, well then just wait for me, because I'm going to solve it here for you. Now, I highly recommend that you try it by yourselves. If you have the answer, don't worry then. Let's throw ourselves to find the solution to this corresponding graph. So let's begin by finding the first one. So the first one is f of 0. In this case, it's 5 with the opposite of 0, minus 3. 5 with the power 0 is always 1. And then 1 minus 3, it's a negative 2. That is f of 0. Then we have f of 1. Let's see if we can make the perfect graph here. Okay. F of 1, that would be f negative, that will be 5 with a power negative 1. It's negative 5 with a negative 1, and then minus 3. Okay, let's see, because it's not collaborating here. 5 with a negative 1, and then minus 3. This is the same as 1/5. Minus 3. And remember that 1/5 is the same as 0.2. So 0.2 minus 3 is negative 2.8. So we have that value there ready. And then finally f of negative 2. So that would be 5 with a negative 2 minus 3. That's the same as 1 out of 5 with a power 2 minus 3. That's the same as 1 over 25 minus 3. And the answer, you can find the answer directly by using your calculator. Now 1 over 25 is exactly the same as 4 over 100, so that's the same as 0.04. So 0.04 minus 3 is 2.96 minus 2.96. Okay. Now once again, the whole idea is that you first find what is the corresponding answer for each one of those three. Once you have the answer, let's see. So we found the answer of each one of those three. And now that we have the answer, you can use your graphic calculator. You plot the graph and then verify that the graph that you have definitely shows those 3 points. So let's do it over here very quickly. So let's check that the ones we have on top for f of 0, f of 1, and f of negative 2 is exactly what we have here. So let's write down the answers. We had negative 2, negative 2.8. Okay, so those are the answers. Negative 2, negative 2.8, and negative 2.96. Perfect. So let's check that the 3 points that we've just found are exactly the ones that we have on the graph. Remember the graph? You should be able to draw the graph by using your graphic calculator. So very quickly, let's see if this works. We have on 0, the answer is negative 2. You have it over here. That's perfect. On 1, the answer has to be almost 3, so it has to be negative 2.8, I'm sorry. It's around there. And then finally with negative 2. Okay, I just realized that I made a small mistake here. Let's make the correction. You might have noticed the mistake that I've made. Take a look at the number I'm using here is negative. So that means that this expression over here is wrong, right? It should be 5 with a power 2. So that means that this should be 25. I'm sorry for the mistake. Meaning then that this is not correct. The answer should be 25 minus 3, that's 22. The answer has to be positive. Now, how do I know that I made the mistake, right? Because I immediately noticed that from the graph. Take a look at the graph. I was supposed to graph f of negative 2. And what I have here is a negative number. It cannot be negative. Take a look at, here is negative 1, so negative 2 is around here. And the function is growing to the left. It's going up very quickly. So if the function is growing up very quickly to the left, of course, negative 2 has to be up, very, very up high here. This has to be 22. And that's how I realized that I made a mistake, right? We started by saying that the answer was negative 2.96, and of course that's not an option if this is an exponential function that is decreasing. Okay, so that's how I know that in this case, negative 2, the answer has to be very, very high, and it should be positive, in this case 22. Okay, very well. So let's rephrase or let's reestablish what we were doing. So we started by finding those three values. Once you have all three, then you can plot them on the graph, or the other option is to use your graphic calculator just to point those three elements. And then once you have a shape that looks like an exponential function, then you can connect the dots. Now, important before we finish with this section, take a look, there is an asymptote over here that, let's erase this. So the asymptote is on this direction. Take a look that as you move to the right, the function is getting closer and closer and closer to y equals -3. And this is important because remember, this is an exponential function, so the asymptote must be part of the graph. And that's it. That was the two exercises that I wanted you guys to try. Remember that in any case, if you guys are trying any of the exercises by yourselves, you can always pause the video, try the exercise, and then come back when I check the answer. Now, just a reminder, because of course this was a big change. There was a small mistake here, right? I was using -2, so the answer was not negative. It should have been positive, 5 with the power 2. So please check on your notes that you have the correct value. If you were shouting at me because I made a mistake and I never realized about it, I'm so sorry for that change. But after I got to the graph, I realized that, yeah, well, number -2 should have been with a very big number, in this case, 22. Okay, perfect. Now, what's going to happen next is that we're going to start working with exponential equations. That's going to be for our next class. For now, I'm going to leave it here. We've had enough with drawing functions, so no more for today. This is long enough for you guys to take some notes and to be ready to show your evidence of your work on your notebook. But for next class, we're going to focus on exponential equations. This will require a little bit of algebraic manipulation on some of the expressions. I'll talk about that on the next session. For now, we're going to leave it here with a few exercises regarding graphs. Take a look how we're now working with exercises that involve a big combination of exponential expressions, either like this one, that as you move to the left it grows very fast, or like this one that has the other type of behavior. As you move to the right, the function is growing very fast. Okay, perfect. Let's stop here then, and let me remind you guys that as we come back to lesson number 3, we will be solving equations, but with exponential